Hello, it's Keith here, and this is lesson 2 of the ChibiTracks series of my 6502 assembly programming tutorials. Now, in lesson 2, we're going to be looking at the start of the ChibiTracks code. Now, what is ChibiTracks? Well, ChibiTracks is my multi-platform music player. And here it is running on the BBC, but it runs on all of the 6502 systems in my tutorials. Now, lesson 1, we looked at the actual file itself. The source files with the music in them are actually ASM files themselves, and that was actually part of the Z80 series officially, but it's an ASM file with a bunch of DB and DW statements, so it will work in any on any system. So please see that that lesson if you want to see the full source file, ASM file of the music. We're going to briefly look at parts of it where relevant in this episode, but as I say, if you want to see the full details, please go and take a look at that. Okay, well, let's go over to our source code and let's take a look at what we'll be looking at today. So here is one of the ASM files which makes up the song data, and we're going to see the header loaded in and the song initialized in this episode. So the file we're going to be looking at is the multi-platform ChibiTracks file. Now this is the actual player, and we're going to be looking at the part that loads in the header and initializes the playing. Now the first thing to note is that there are some options with regards to ChibiTracks that change the way that it works. These increase the functionality but increase the size of the program. So one of these is the allow speed change option, and this allows the playback speed to be altered in playback time. Now the alternative option is to compile it into the music's file itself, pre-compiled speed it's called, so that can be added at export, but if it's disabled we can change the speed at the playback time. And the advantage of this is if we've got 50 Hz and 60 Hz systems, we might want to change the playback speed more flexibly than pre-compiling it in. That allow speed change will do that. The other one is allow relocation. Now, when we export a binary file with the ChibiTracker Pro software, we specify a load destination, so maybe a memory address 8000 or something like that. But what happens if on the destination system we want to load it at memory address 9000? Well, the internal logic of the binary file will have the original compile address loaded into it, and that would cause a problem if we don't allow relocation. But if we allow relocation, what this does is it calculates the difference between the address the file was exported for and the address that it's been loaded into, and it offsets all of the internal memory addresses by that amount. The result is that it will play from any address, but the allow relocation will slow down the playback and increase the size of the program in the same way as allow speed change will. So it's up to you. You can have extra functionality and less memory and slow speed, or you can have maximum memory and maximum speed but less functionality. If we enable allow speed change, we need a subroutine to do this, and this speed mult routine will basically multiply the accumulator by whatever the song speed is. It's a very crude multiply routine here, and that is used when allowed speed change is enabled. Now, when we want to actually start playing a song, we need to actually initialize the song, and what we do is we run ChibiTracks start song. Now, I've got a song file in assembly here. This is an assembly file. This can be played. The assembly files are used by ChibiTracker Pro as the file format for loading and saving songs that are being edited, but they can be compiled to binary, and actually this can actually be played by the ChibiTracks player you're seeing today. So this is the literal byte data that will be loaded in by the code you can see here. So the first thing we're doing here is we're going to initialize the data that is used by the ChibiTracker software for the current state of each of the channels. Now you can see the template format, if you will, here for the various data that each of the channels uses. There's a note number, there's a volume, there is a channel number, and also the top bit of that is also the noise state. There is a pitch shift. That's used with the note to calculate the final 16-bit frequency. All of these settings are passed to the platform-specific driver, which is known as ChibiSound Pro. I've written a matching driver for each of the systems in my tutorials, and this ChibiTracks software works on all of them, so that it's a common piece of code. It's that ChibiSound Pro driver that does the platform-specific work. We've then got pointers to the current playing line of the instrument and the timeout for the line of the instrument. We'll see those in a moment. We've got an address pointer for the current line of the pattern data and the timeout for that line of the pattern. We then got the address of the sequence, which is the order of the patterns that should be played on this channel, and a few unused bytes. And we've then got pointers to the various offsets within the channel for those pieces of data. The ChibiTracks software, as it currently stands, is designed to support 3 channels, 0, 1 and 2, and so we've got offsets to those within the Chibi Sound RAM. On each of the systems, Chibi Sound RAM will be pointed to an address which can provide 128 bytes or so of memory that can be used for ChibiTracks and also the Chibi Sound Pro data. It's the platform specific drive, which in some cases needs a few extra bytes. So that's what we've got there. Now, at the start of the initialization routine here, the first thing we're doing here is we're zeroing all of that memory so that all of the bytes are basically 0. This is a fairly decent startup state. Obviously, we want to make sure there's no junk in there, but there are a few exceptions that we need to do. The first thing we need to do is we need to set the channel numbers of the bytes in there at position 2, and we need to set those to the current channel number. So 0 for channel 0, 1 for channel 1 and 2 for channel 2. The other thing we need to do is we need to point to a valid instrument and to a valid pattern, but we're actually going to set that up later. Now, there is a valid instrument of sorts here for the silent instrument, which is basically a single line of 0. The 0 here is actually the time until the next line. We'll see that in a later one. This example here had a line of 1, but 0 is actually the end of instrument parameter. When there's a time of 0, that's the end of instrument. So that is the absolute minimum, which is an instrument that just announces it's already ended. So we'll see that later on. Now, after we've zeroed all of our data and set up those initial channel numbers, the first thing we're going to do here is we're going to load in our song. So what we're doing here is we're loading in the song base into HL here. The song base memory address must be loaded with the address of the data file that's going to be played, so whatever that is in the actual memory. Now, what we're then going to do is we're going to load in some parameters and store those in various entries in memory here. So the first thing we're loading here is the number of song channels. Then we're loading in the repeat point. This is an offset to the pattern that we will repeat back to when the song ends. And then we're loading in the song speed here. Now, if we look at the song here, you will see the number of channels here is the first byte here. The repeat point is the next byte, and the song speed is the byte after. The following 2 bytes are my song, which is the address that the song was compiled to. Now, this is an assembly file, so there is no address it's been compiled to. But if you've exported a binary, this will be the address of the binary that you specified when you exported the binary. And so what we're doing here is we're loading in that song address into the DE pair in the 0 page here. Now, what we're then going to do is we're going to calculate the offset, and this is needed if we are going to allow the relocation. So we're calculating that offset here. And then what we're doing next is we are loading in the address of the pattern list and also the instrument list. Now, these are also in the header, and these are pointers to basically the vector tables for the addresses of the numbered patterns and the numbered instruments. And you can see that the script data for the patterns and the instruments in the rest of the file. Now, that's what we're doing there. So here we're loading in those initial addresses here. And then what we're going to do is we're going to initialize each of the channels based on the data for the song sequence. So what we're going to have to do is we're going to have to load in the addresses of the patterns that we want to play. Now, the sequences you can see here, there's an address pointer to the sequences, and the sequences are a set of numbers that represent the patterns that we want to play. So this channel 0 wants to play pattern 0, pattern 0, pattern 3, pattern 4, and so on. 255 is the endpoint, and here's the equivalent for channel 1, and here's the equivalent for channel 2. So that's what we're going to do here. For each one, we are going to run this initialize song sequence routine, which will load in the pattern, and then we run get next channel, which simply moves us to the next channel. We're just adding the channel data length to the IX pair there in the 0 page. So how does this initialize song sequence work? Well, basically what we're going to do is we are going to load in a pattern. Now, one thing that's a bit odd with this is the first time we will start from the entry 0 within the song sequence, but the repeat point will change that. And so in that case, we're loading the pattern we want to offset by into the C entry in the 0 page here. And that will be 0 the first time, but it will be whatever the repeat point is the other time. So if that was 1, we would skip channel pattern 0 here, and we would start from pattern 1. Or if it was pattern 2, we would load from there, and so on. So we're going to see that represented in this init song sequence. So what we're doing here is we are getting the address of the sequence, which is the next thing that's being pointed to when this is executed. So basically what we're doing here is we are loading in this address here for the first time. And then what we're doing next, if we are allowing relocation, is we're adding the offset of the song to that, and then we're going to run get next sequence, which is going to calculate the next sequence that we want to play, and we'll see that in just a moment. What we're doing next is we're storing HL that will have been calculated by this get next sequence into the current playing channel data. That's the address of the pattern. We're then setting the instrument, the playing instrument, to the current silent instrument here, and that is basically so that the instrument does nothing there. And we're setting the instrument time, basically forces the instrument to update next time, and that will silence the channel basically because we're loading the silent instrument. Now the get next sequence routine here, basically what this is going to do is it's going to load in the sequence. So what we're doing here is we are loading in a byte from the sequence, and if it's a 255, this is the end of the sequence and the song has ended. You will see that each of the sequences ends in a 255 here. That's the end of the song and a call for the repeat. This is just some test code here. Now what we're doing here is we are calculating the sequence as an offset. We're going to basically add this to the address in the pattern list, and that will be the address of the actual pattern data. And then what we're doing here is we are updating the new address for the sequence. The channel has a pointer to the next byte of the sequence that it needs to read in next time it needs to update, so that will be pointing to one of these bytes here for this channel. So that's what we are doing here. What we're doing next is we are calculating an offset within this pattern list with the pointers to the actual pattern scripts, and you can see these scripts here, and that will be played by the code we'll see in a later episode. So that is what we are calculating the address of here. We're then adding the song offset if we are using song offsets, and then we're basically forcing the pattern to update at the next tick, and we're returning with the HL pair pointing to the pattern, which we will store back into the channel memory with these commands just here. Now this is also being used when the song ends. The restart song routine will basically clear down the stack, removing all the remaining items on the stack. It will load in the repeat point into the accumulator, and it will then run start song again. Now start song again actually reloads all of the initial data to get to the correct memory position anyway, but this accumulator will be loaded onto the C entry in the 0 page, and then that will be added to the pattern position for when the initialization of the get next sequence is executed here. So that's being added there to the current address of the sequence for when the pattern is being replayed there. And there we go. So that's all we're going to be looking at today. Now next time we're going to go into the code that actually starts to actually play the instruments. So we'll be seeing more of the code there. And the interesting thing about this is the scripts for the patterns, the actual events that happen during the playing of the pattern, and the scripts for the instruments are actually the exact same scripts. They're handled by the same routine. That made the code a lot less code to debug, a lot less code in total. And I think it worked reasonably well. As I was saying, you can go to my website, download the source code, the build scripts, and you can have a go with this yourself, and you're welcome to use it in any way you want. I hope you found this interesting. If you have, please like and subscribe, and if you want to see more work on ChibiTracks multi-platform music tracking software, please consider backing me on Patreon. Hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.